Hi, my name is Emma Signator, and I'm going to be, this video is going to be showing you, what the Pythagorean theorem is, and what special right triangles are, and the two different types of special right triangles. So the objective for this lesson is to understand what special right triangles are, and use the Pythagorean theorem to find missing aspects of right triangles. So first, what is the Pythagorean theorem? The Pythagorean theorem is the theorem/equation that is used to find the sides of a right triangle. And the equation for that is c squared equals a squared plus b squared. And as you can see in the diagram right here, you can see that c is the hypotenuse, which is the longest side of the triangle, where B and A are the legs of the right triangle. They are the two other sides of the triangle. Alright, just to give you guys an idea of it, we're going to do a little quick practice problem. And I will be doing it with you on a separate piece of paper. So we see that the triangle here is labeled with a side 12, a side 9, and the hypotenuse of x. So if we go back to the diagram, we can see that the hypotenuse equals c, and the two other sides are a and b. So let's go back and c, the hypotenuse, is x. So we write out the first part of the equation as x squared, and like I said before, 12 and 9 are the legs. Realistically, it doesn't really matter which one you put in for A or B, but just for today's lesson, we're going to put them in the correct spot according to the image. So 12 is in the spot of A. So it'll be 12 to the power of 2 plus 9 to the power of 2, because 9 is in B. So your first portion of the equation should look like this. It should be x squared equals 12 to the power of 2 plus 9 to the power of 2. So now what we have to do is you want to get your calculator. And x squared we can't solve yet, so we leave that the exact same. And then we do 12 to the power of 2, which is 144. And then we do 9 to the power of 2, which is 81. So this is what our equation looks like now. Now what we got to do is do 144 plus 81, and that gets us to 225. And now what we do is we need to find the square root of both sides of the equal sign, because the x has the little square up there. So we find the square root of each side. The x squared just becomes x because the power of 2 and the root cancel out each other. And then in our calculator, we do the square root of 225 is 15. So now we know that the hypotenuse side of this triangle equals 15. Alright, now I'm going to explain to you the two different types of special right triangles. The first type is isosceles right triangles. Isosceles right triangles are triangles that have two legs equal the same length and two 45-degree angles. This is also known as the 45, 45, and 90 right triangle. As you can see in the diagram right here, you see that there is both a 45 and a 45 and a 90-degree angle. See that the 45 and the 45, they're congruent, they're the exact same, which means that the legs would be the exact same. The only thing different would be C. Alright, and the other type of special right triangle is the scalene right triangle. A scalene right triangles are right triangles that have two different leg lengths and three different angles within the triangle. It is also called the 30, 60, and 90 right triangle. This theorem is also used to find half of the area of an equilateral triangle. So as you can see in the diagram, the whole triangle itself, all of the blue, that is an equilateral. As you can see, half of it, which has the degrees and the 90 degree, that is a scalene. So it shows that it is half of a equilateral triangle. Alright, so now we're going to do some practice to see if you guys fully understand. I'm going to walk through them with you, don't worry, but we're just going to see if you can fully understand the concept of material. So this first question is asking for us to figure out what is x, and then what kind of special right triangle is it. So we could do these questions in really any order, but we're going to solve, for this one, we're going to solve for x first. So we got the equation right there, c squared equals a squared plus b squared. Now, we got to locate which number goes in which. And c, again, is the hypotenuse. So we can see that the number 23 is in the spot for c. So we substitute c for 23, put that to the power of 2. Now, we got to figure out what a squared is. In the diagram, in the spot of a is 10. It is one of the legs. And then we are solving for x, which is in the spot of b. So your equation should look like this. It should be 23 to the power of 2 plus 10 to the power of 2 plus x squared. So now, like before, we do 23 to the power of 2, which is 529, 10 to the power of 2, which is 100, plus x squared. And from there, we subtract 100 from each side, which gets us to 429 equals x squared. Now what we do is we find the square root of each side. The 2 above the x cancels out, and the square root of 429 cannot be simplified into a simpler, smaller, I call them smaller square roots. I call them smaller roots, but it cannot be simplified. So your answer can be the square root of 429, or if the instructions are asking for a decimal, you would get the answer of 20.71 centimeters square. And you want to make sure the unit is centimeters square because in the diagram, you're multiplying centimeters together. So you want to make it centimeters square. And then now, we got to figure out what special right triangle it is. For this, I first look at the angle measurements, the angles of each point. I see there's a 60, a 90, and a 30, which tells me that that is a scalene right triangle. You can also kind of look at the image of it. That helps as well. All right, let's move on to number 2. So for number 2, it is again asking what is x and then what kind of special right triangle is it. So we have the basic formula. And now what does c equal? Oh wait, actually, with this specific question, we are going to first figure out what type of special right triangle it is. Because as you can see in the picture, there's both a y and an x. So we got to figure out like what to do. So let's first figure out what type of triangle it is. We see that there is a 45, a 45, and a 90-degree angle, which tells you it's an isosceles. And another thing, like I said about isosceles, is that the leg sides are equal. So we see that A equals 8. And since the sides equal, we now know that Y is 8. Because again, for those type of right triangles, the legs and sides are the same number. They're the same measurement. So for C, we are again solving for x, which is in the spot of C. So we have x squared equals x squared plus 8 squared plus 8 squared. Because again, since it's a isosceles right triangle, they have equal leg length. So now we got to do 8 to the power of 2, which is 64. 64 plus 64 is 128. Which now we got to find the square root of 128. Once again, that square cancels out over the x, and the square root of 128 can be simplified simplified, thankfully, and we get the simplified answer of 8 to the square root of 2 centimeters squared. And again, in decimal form would be 11.31 centimeters squared. And then again, like we stated before, this is a isosceles right triangle because of the angles. And it thankfully helped us before figure out what y was. Alright, let's move on to example number 3. Same thing. What is x and what kind of special right triangle is this? Okay, we have the equation. And now what we're going to do, like normal, is we're going to substitute the numbers into the spots. C is the hypotenuse, which number 15 is located at. So we have 15 squared equals, and then A is x. So we will be solving for A, solving for x, but x is an A spot, plus 13 squared, because 13 is in the spot of B. Now we do 15 to the power of 2, which is 225. X squared stays the same. And then 13 to the power of 2 is 169. Now what we do is subtract 169 from each side, which is 56 equals x squared. Find the square root of each side. And the square root of 56 can be simplified as well, which gets us to the simplified answer of 2 to the square root of 14 centimeters square. And again, a decimal answer of 7.48 centimeters square. And now, what type of special right triangle is this? We can look at the angles and the image, but I see the 30, 60, and 90 degrees, which tells me that it is a scalene right triangle. All right, now for the final example. I know it's kind of scary seeing the square root of 10 on the sides of a triangle, but don't worry. It is okay. It is doable. So, again, we want to simplify each portion of the diagram into the equation. X is in the spot of C. So we first have x squared equals, and 10, the square root of 10 is for both each sides of the legs. So both A and B will be the square root of 10 to the power of 2. So your equation will look like this. And you may think, well, how do you bring that to the power of 2? Think to at the end of the past examples, when we would find the square root of x to the power of 2, the x in the square root would cancel out. That same thing would happen here. So since the 10s have these square roots, that 2 cancels them out. So the equation will only turn to 10 plus 10. It's kind of simple. It really is. It was scary at first, but it's simple. So now it's just 10 plus 10, which is 20. And now, like normal, we find the square root of each side. The square cancels out on the x. And the square root of 20 can be simplified to 2 to the square root of 5 centimeters squared. And again, in decimal form, 4.47 centimeters square. And we can look, to figure out the special right triangle with this, we can look at the angles again, but then we can also look at each side is 10, or square root of 10 centimeters. And that tells us that is a isosceles right triangle. Alright, that was it. I hope you guys understood me explaining what the Pythagorean theorem is and the different types of special right triangles. And I hope you guys enjoyed and learned a lot.